In this second part of the video, we'll be creating an endpoint to establish a WebSocket connection, create a room, get rooms, and get clients in the room. So to give you a quick demo on how this is going to look like, when a user hits the create room, that's going to hit the create room endpoint. And when a user joins the room, that's actually when the WebSocket connection is established, and the user will be able to start exchanging messages through this WebSocket connection. So before I send this message, I have a separate incognito page where a user 2 will be able to join the room as well. And that's gonna display a new user has joined. And when a user sends the hello message, the second user will be able to receive this message, and so on. Let's first have an overview of how our architecture is going to look like. First, we have the hub, which is the central place that manages different channels, and it has a map of rooms, and it will be running on a separate Go routine. And we have channels for registering and unregistering a new client, and a broadcast channel that receives a message and broadcasts it out to all the users or the clients in the same room. And of course, we can have multiple rooms. And if we look into each of the room, it first has no client, and only when a client hits the join room endpoint, that will create a new client that will be registered through the register channel. And if we look into each of the clients, we have a write message and a read message method associated with each of the clients, where a read message reads the message through the WebSocket connection and send out the message to the broadcast channel in the hub, which will then broadcast it out to each of the clients in the room. And the write message method will write this message to the WebSocket connection, which will then be handled on the front end side to display the messages accordingly. So now that we have looked at how our architecture is going to look like, we can get started right away. Inside this internal directory, I'm going to create a WebSocket package, and inside that, I'm going to create a hub. And I will start off with the create room endpoint that will allow us to, of course, create a room. And inside this hub, I'll first create the hub struct, which will include a map of rooms that maps the room ID to the room structure. And of course, we need the room struct, which will have an ID, a name, and a map of clients. So of course, we have to create this client struct. I'm going to create it in a separate client.go file, which will be under the WebSocket package. And inside this client struct, we have a connection, which is the WebSocket connection, and a message channel that's of type a pointer to a message, which I'll actually create here. So a message struct that has a content, which is the actual message, and a room ID that this message belongs to, and a username of this message. So if I save that real quick, that's gonna import the WebSocket from GoFiber, but I'll be using a WebSocket from Gorilla. So I'll need to do go mod tidy so that it finds the package and imports it accordingly. And now that we have the WebSocket connection and a message channel, we still need the ID for the client, the room ID of this client, as well as the username. So now that we have defined the client struct, let's come back to the hub. this actually needs to be client, save it, and we're gonna define the constructor for the hub. New hub that returns a pointer to the hub that includes room, which we'll just instantiate here like this. We'll call this new hub from the main.go later. We first need the WebSocket handler. So I'm going to create this WebSocket handler file, and inside here, I'll create the handler struct that will have a pointer to the hub, and a constructor for the handler that receives the hub and returns a pointer to this handler, and a pointer to a handler that has a hub, and a handler, a create room method for this handler that receives a Gin context, since we're using the Gin framework. So when we create a room, we'll be receiving the ID and the name of the room. So I want to create this create room request struct that receives an ID and a name. And we can define this request variable and use the should bind JSON to bind the JSON to this request variable. So if there is an error, I'm going to do a quick error handling saying it's an HTTP status bad request, and just return here. So using this information that's passed in, I'm just gonna store it in the rooms map inside the hub using the ID of the room. And here we're gonna have a pointer to the room that has the ID from the request, name, again from the request, and the clients, which will just instantiate here. Client, like this. And once we do that, we're gonna say status okay and send the request out. So as you can notice here, we are only storing the room information in memory, and we're not storing the room information in a database like how we did for the user information. So now that we have defined the create room handler, we can go to main.go and instantiate our hub. So we can just call the new hub function and then pass it down to the WebSocket handler that we just create with the constructor. And then I'm going to pass this WebSocket handler down to the init router. And of course, we have to redefine this parameter for the init router. It's going to receive a WebSocket handler that's of type WebSocket.handler. And then I'm going to create a endpoint for this create room by calling the WebSocket handler.create room. And once I save this, the error in the main.go file is gone. And if we actually test this real quick, I already have Postman open for us. So I'm going to hit this ws/create room endpoint. And it's going to give us the request back. And we can also see the 200 status okay here. So the endpoint is working. So now that we can create a room, Let's move on to joining the room, which will establish the WebSocket connection and play the most important role in this chat application. So I'm going to start from the WebSocket handler here, which will be just like creating the room. So join room that receives a gin context like this. But in order to establish the WebSocket connection here using the Gorilla WebSocket, we first have to define a variable called upgrader. And this is very well documented in the Gorilla WebSocket documentation, which I'll include in the description box below. But we just have to define this upgrader with a read buffer size and a write buffer size as such. And we're also going to have the check origin that receives a request, returns a boolean, and we're just going to return true in all case for now. But if later you want to specify your origin to, let's say, the path to your front-end application, you can actually specify the origin by getting it from the header and then return origin to be equals to, let's say localhost 3000. That's one way to go about it, but because I'm going to be testing this on Postman, I'm just going to return true in all case. So now that we have the upgrader, we can call the upgrade function on the upgrader that receives a writer and the request from the gin context. And this is going to return our connection variable and do a quick error handling that specifies status bad request. And our join room path is going to look something like this, where we have the room ID as the parameter, as well as the user ID, let's say 1, and the username, let's say user, like this. So in order to read these parameters, I'm going to first call the c.param that reads the room ID like this, and the user ID, which I'll just call it client ID, that I'll be reading from the query, as well as the username. And now we can define our client using this information. First, we are going to pass in this WebSocket connection and instantiate the message channel. This will actually be a buffer channel of size 10. And the ID of the client will be the client ID from above. And the room ID will be the room ID again. And the username like this. And we're going to create a new message which we want to broadcast, saying that a new user has joined the room. So the content would be something like a new user has joined the room, which will be broadcasted to different clients in the room, and a room ID as well as the username. So if you remember from the diagram earlier, there are a few things that we have to do at this point. First, we have to register this client through the register channel. And we also want to broadcast that message. And then later we will be calling this write message method, as well as the read message method here. But before we do these two, let's first create the channels to register and broadcast the message. So it's going to look something like this, where we actually pass this client information through the channel. And we're also going to have a broadcast channel, which will pass the message into. I actually forgot to add comma here and here. And this has to be username. Now let's define the register and broadcast channel in the hub. So inside this hub, we are going to define a function called run, which will run on a separate Go routine. And we'll define this in the main.go file later. And this will have a for loop. And inside this for loop, we're going to have different cases that receives a client information through the register channel and through the unregistered channel, as well as a message that we receive from the broadcast channel. But in order to actually receive that, we first have to define this inside the hub. So first we are going to have the register channel of type pointer to the client, and the unregistered channel, as well as the broadcast channel of type pointer to the message. And inside the constructor, we have to, of course, instantiate this unregistered, as well as the broadcast channel of type message, and this will be a buffer channel of size 5. So when the hub receives the client information through the register channel, it will first have to check that the room ID actually exists. So inside the rooms of the hub, it's going to call the room ID and check if it exists. So only when it exists, then we can call the room by using the same approach, and then add this client to the room by calling the client's map inside the room with the client ID as the key and the client as the value. But before we add this, we actually want to check if this actually doesn't exist already. And if this is not okay, then we will add this client to the room. And the unregistered channel is not too different from the register, but there are multiple things that we have to check. First, we have to check that the room ID exists. So only when it exists, then we want to check if the client already exists by calling the clients, that client ID. And if the client actually exists, then we want to delete this client, or delete this client ID from the rooms, or that room from the client's map like this, and close the message channel of the client. And we might also want to broadcast a message saying that the client has left the room. But let me first define this broadcast channel. Inside this broadcast channel, we're going to check if the room exists again. And if the room exists, we are going to send the message to each of the clients in the room using a for loop. So I'm going to specify the room ID, and to each of the clients, we're going to send this message through the message channel of each of the clients. So it's as simple as that. And let's just complete this part here, where if we actually have more than one user, or if we actually have some users in the room still. So if this is not 0, I'm just going to create a message and send it to the broadcast channel. So here I define a message where the content will be something like user left the chat. Room ID will be from the client, and a username from the client. So those are the 3 channels that the hub will be managing inside the run function. And before we forget, let's actually call this run function from main.go. So inside main.go, I'm just gonna run this on a separate Go routine by calling the run function like that. And let's actually go back to the WebSocket handler. Now we have to define this write message and the read message that will read the message from the WebSocket connection, and also the write message that writes to the WebSocket connection, if you remember from that diagram. So this will be defined in the client file, because reading and writing the message is for each of the clients. So here, I will define this receiver client and create this write message method where we would actually close the connection at the end of this. Remember, we need the brackets here. And then define an infinite for loop where we'll be receiving the message. And if this is not okay, I'm just gonna return. If not, I will write it to the WebSocket connection by calling the write.json method and passing the message here. So writing the message is pretty simple. So if you remember, we get this message through the message channel when a different client broadcasts that message to this specific client. And below here, I'm gonna define a read message method that receives a hub, because I want to actually unregister a client inside this defer function by calling the hub. So here, unregister, receive a client, and close the connection for this client. Again, brackets here. And inside an infinite for loop, I'm going to call the read message on this connection, which will return 3 different variables: message type, P, which is the message itself, and the error. So I don't need the message type, but I'll handle the error real quick. So this is from the documentation itself, but you can check the WebSocket error to see if it's a WebSocket close going away, or WebSocket close abnormal closure. And if so, I'll log it out. saying error like this, and just break it out just for any errors. And if we don't have any errors, then we can define this message, and the content will be the message itself that received from the connection, which will cast it into a string type, and a room ID from the client, and the username of the client. And with this message, we can broadcast it to the hub like that. So now that we have defined these methods, we can call this from the join room handler. And let me delete these comments and also these here. And I'm going to call this read message on this main Go routine. But for write message, I want to create a separate Go routine to handle the writes. And that is it for the join room handler. We just need to now add it to the router. So this is actually going to be a get, where I will have a WebSocket join room and the room ID parameter that will be receiving. And here I'm going to pass the WebSocket handler.join room handler. And as you might have assumed, we will establish a WebSocket connection by hitting this endpoint. So if we were to test this on Postman, I already have this created here. But if you want to test it yourself, instead of just creating a new request here, you actually have to click new here and click on this WebSocket request. That will then create the WebSocket request where you can specify the URL, which I defined here. And of course, this will start with the WebSocket protocol, and then you can specify your path and the room, as well as the user ID and the username like this. And let's just see if this WebSocket connection works. But first we have to run this. So run cmd, no, go run cmd main.go and click connect. So we can see that the connection has actually worked. And let's see if we can actually pass any message here. And we can see this message is being sent out. But that's actually all we needed to see, that the connection has established successfully. So I'm going to disconnect and come back here. And there are two more endpoints that we need later, and they are much simpler. So let's actually go ahead and create them. The first one will be getting the rooms. So it's just going to be get rooms handler get rooms. And let's go into the WebSocket handler. So down here, I'm going to call the handler receiver and find this get rooms that receives age in context. And when a user requests for rooms, we're going to send a list of rooms that contains an ID and the name of the room. So I'm just going to define a struct called room response, where it's going to have the ID of type string as well as the name of the room. And inside here, I'm just going to define a list of rooms, call it rooms, and inside a for loop, we're going to call the rooms in the hub and just append this information by defining the room response for each of the room, and the ID will be the ID from the room as well as the name, and pass it saying status okay, and the rooms as the response. And now that we have the get rooms, before we test this endpoint, let's actually create the get clients method as well while we're here. So this will be a handler receiver again that get the clients in the room. So just like above, I want to define this client response struct that has the ID and the username of the client. Username. And of course, we would only be interested in getting the clients for a specific room. So we are actually going to receive the ID of the room through the parameters, which will call the cThat_param to get the ID. But before, we also want to create this clients. That would be a slice of client response. But if there is no room with that specified room ID, so if it's not okay, we're going to create an empty slice of length 0 and return it to the user. So status okay and clients. If that's not the case and we actually have clients in the room, we can just loop through the clients and append it to the client slice. Client response, where the ID will be the ID of the client, and the username will be, of course, the username. And we're just going to return this. Okay, and clients. Like this. And let's just call this method from the router. So here, this is a get request. We'll get clients, but we also need the room ID parameter, websocket handler dot get clients. So everything is ready now. Let's go and test it on Postman. So go run cmd main.go. We can see these 4 endpoints are running. So let's first create 2 or 3 rooms. First we have room 1, room 2, and room 3. And we can get the rooms through this endpoint, and it will give us the response, a list of 3 different rooms. And let's see what happens if different users join the room. So we're going to try to join the first room where room ID equals 1 using user ID equals 1. So let's say a new user has joined the room, and let's copy this here and say a different user joined. Let's say user ID equals 2 and the username equals user2. Now another user has joined the same room, and if we try to get the clients in room ID equals 1, let's see what happens. So we can see 2 different users that has joined the room, and we can see the endpoints are working as expected. So that's all there is to establish the WebSocket connection, create the room, get rooms, and get clients in the room. And just for your information, some of the logic in the hub and maybe the WebSocket handler might not be very accurate at this point. So it's of course open to changes. and might get updated, but that's all we need for now, and things are working as expected. And in the following parts, we'll be working on the front end to display the rooms and the messages accordingly. Thank you all for watching.